January 1951. London. Rosalind Franklin stood in a new laboratory. She rolled up her sleeves and inspected the equipment. Her eyes were steady. She was not a scientist who moved on emotion. She was a scientist who moved on evidence. Her appointment at King's College. The mission was clear: to unlock the structure of DNA through X-ray crystallography. At the time, DNA was drawing intense attention as the molecule holding life's secrets. But its structure remained unknown to anyone. Franklin reached out and touched the apparatus. The answer must be here. But this place had a problem. Her colleague, Maurice Wilkins. Partly due to unclear communication from the laboratory's leadership, he assumed Franklin was there to assist his research. Franklin was an independent researcher. But Wilkins refused to see it that way. British academia in the 1950s. It was not yet taken for granted that a woman could lead her own research. Franklin knew this battle would be fought on two fronts: the battle with DNA and the battle against prejudice. But she did not break. She turned to her equipment. She focused on building the evidence. Franklin accumulated data. In time, a crucial discovery came. DNA exists in two structural forms. Depending on conditions such as water content, it displays distinct diffraction patterns, Form A and Form B. Clearly demonstrating this distinction was of extraordinary importance for its time. Franklin had noticed something more. Phosphate groups lie on the outside of DNA. The structural backbone must be on the outside. This insight was correct. But no one was listening yet. May 1952. Franklin instructed her graduate student, Raymond Gosling, calibrate the equipment, prepare the conditions, load the film, and the long exposure began. Taking longer than usual to minimize noise and capture a high-quality diffraction image. Invisible light was tracing the architecture of DNA. Franklin waited. She did not rush. She needed perfect data. She submerged the film in Developer. Slowly, an image emerged. Franklin held her breath. An X-shaped pattern. Beautiful, symmetrical. This image, later known as Photo 51, was an extraordinarily high-quality diffraction photograph that strongly suggested the double helix structure of B-form DNA. Her eyes narrowed. The calculations began. What did this image mean? She understood that this pattern strongly indicated a helical structure, and she set to work confirming it through precise numerical analysis. Franklin continued her calculations. The pitch of the helix, the period of repetition, the angle of the bases, and the space group of the crystal. The data spoke with precision. She was careful. As a scientist, she had no intention of publishing until every number was in place. A claim without evidence is not science. That caution would later become the hinge on which her fate turned. January 1953. Maurice Wilkins produced a photograph. Photo 51. Without Franklin's consent, without a word to her, Wilkins showed that photograph to a young researcher at Cambridge, James Watson. Watson would later recall the moment. His jaw dropped and would not close. The X-shaped pattern. It spoke immediately, unmistakably, of a double helix. Franklin had no knowledge of this. And that was not all. An internal progress report from the Medical Research Council. It contained detailed computational data on DNA that Franklin had compiled. MRC committee member Max Perutz passed this report to Crick under the impression that it was not confidential. That act would generate enormous controversy in the years to come. Recent scholarship in the history of science has revealed something more. It was not only the impact of Photo 51. The precise numerical data Franklin recorded in her report, particularly her calculations on the crystal space group, were the decisive key to constructing the anti-parallel double helix model. Franklin had supported the discovery not only through her photograph, but through her calculations as well. February 1953. In Watson and Crick's laboratory, a metal model was completed. The double helix, bases on the inside, the phosphate backbone on the outside. The structure matched, precisely, the figures Franklin had derived through calculation. The two men were certain. This was DNA. April 25, 1953. A paper was published in Nature. Molecular Structure of Nucleic Acids. Authors: J.D. Watson, FHC. Crick. At the end of the paper, there was a brief acknowledgement that they had been stimulated by the unpublished results of Franklin and Wilkins. But there was no specific citation of Photo 51. No explanation of how Franklin's computational data had been shared. In the same issue, Franklin and Gosling's X-ray diffraction paper appeared alongside it, but it was positioned as supporting data for the Watson-Crick paper. Lead and supporting role. That order was engraved into history. Franklin left King's College, a new place, Birkbeck College. She began researching the structure of viruses, including tobacco mosaic virus. Here, too, she built a body of precise work, leaving a significant mark on virology. She had likely understood that something had been taken from her. Even so, she did not turn her anger against science. She kept building evidence. 1956. Franklin received a diagnosis: ovarian cancer. Every day, she had stood beside her X-ray equipment. At the time, radiation protection was far less developed than today, and exposure may well have elevated her health risks. The role of genetic factors has also been discussed in later years. In any case, establishing individual causation with certainty is not possible. Did Franklin know that her life had been given to unlocking DNA? Even so, she kept returning to her laboratory. April 16, 1958. Rosalind Franklin was gone. She was 37. On her desk, unfinished research remained. Files of X-ray photographs, arranged in careful order. Spring light fell into an empty laboratory. She had gone without ever knowing how history would record her. October 1962. The Nobel Prize in Physiology or Medicine was announced. James Watson, Francis Crick, Maurice Wilkins. The Nobel Prize by convention is not awarded posthumously. This convention would later be codified. But Franklin had not even been put forward as a candidate. Her contribution was never sufficiently made visible, never honored with the recognition it deserved. Franklin had been gone for 4 years. December 10, 1962, Stockholm. In the acceptance speeches, Franklin's specific contributions went unspoken. The rules were followed correctly, but no one in that room asked the question: who had taken that photograph? Who had done those calculations? 1968. Watson published his memoir, The Double Helix. It became a worldwide bestseller, but the portrait of Franklin within it drew sharp criticism from scientists, condemned as demeaning and unjust. Neither her abilities as a scientist nor her character had been treated fairly. Anne Sayre, a friend and colleague of Franklin, later wrote her biography. To set the record straight, 10 years after Franklin's death, 20 years, historians of science began unearthing the truth. Where had Photo 51 been taken? Who had shown that photograph to Watson? How had Franklin's data been shared? The records had survived. The evidence had not disappeared. What Franklin left behind was not only her contribution to the discovery of DNA. She had left behind facts that could not be concealed. 2003, the 50th anniversary of the double helix discovery. The scientific journal Nature published a significant statement. It was not only the impact of Photo 51. The precise numerical data Franklin recorded in her report, her calculations on crystal structure, had been the decisive key to building the model. She was not only a victim whose photograph was taken without consent, she was a scientist who had logically derived the double helix through data and mathematics. Around the world, that understanding began to take hold. In the 21st century, Franklin's name is spoken in classrooms everywhere. She is now recognized as a scientist who made decisive contributions to the discovery of the DNA double helix, and as the most painfully resonant symbol of sexism in science. In recent years, her case has been treated not only as a symbol of discrimination against women, but as a vital case study in research ethics, teaching how scientific data should be shared, how consent should be given, and how credit should be assigned. Photo 51 still exists. That single image, created by Franklin and Gosling, analyzed by her. The evidence did not disappear. What can we learn from Franklin's story? She did not rush. She refused to publish until the evidence was complete. That integrity, it could be said, created an opening that others exploited. But integrity itself was not the mistake. The problem was an environment where integrity was not protected. What she teaches us is this question: are you leaving the fair recognition of your own work in someone else's hands? This is not only true in science. In business, in organizations, this question is alive. Proving your results is not enough. You must also protect who those results belong to. So here's the question for you. History only tells us the outcome, but those who lived it had no idea how it would end. If you had been in Rosalind Franklin's position, what would you have chosen? Precision? Speed? Or a strategy to defend your own work? And ask yourself, is there a Franklin around you whose contributions go unrecognized? Let me know your thoughts in the comments. Thank you for joining me on this journey. History is not only the story told in the light. There are those who moved history from places no one could see. Here, on Blueprint of Giants, we follow the decisions and struggles of those very people. If you want to know the real stories behind the world's greatest achievements, subscribe and turn on notifications. Until next time.